Good morning, my dear students. In the previous two video presentations, we have discussed some problems meant for class 12 of CBSE with answers. In this particular video presentation, we will continue with some more problems with answers which are meant for class 12 of CBSE. The first problem meant for today goes like this. A random variable x has the following probability distribution. X takes values 0, 1, 2, 3, 4, 5. The corresponding probabilities are k, 2k, 2k, 9k square plus k, k. Find, there are three subdivisions. Subdivision 1, find k. Subdivision 2, find p of x less than or equal to 2. Subdivision 3, find p of x greater than or equal to 3. This is the question, just see. I am not going to write the question again on the board. I'll just discuss the answer directly. Just see the question for a minute. Let me just start with the answer. Okay, let me write x values 0, 1, 2, 3, 4, 5. The corresponding probabilities, we just call it as xi here. We call the probabilities as pi here. They are given to be k, 2k, 2k, 9k square plus k, and of course k and then k. P of x equal to 0. Probability for 0 is k, probability of 1 is 2k, for 2 is 2k, for 3 it is 9k square plus k, for k 4 it is k, and for 5 it is k. I am supposed to find the value of k, and I am supposed to find p of x less than or equal to 2. I am supposed to find p of x greater than or equal to 3. Just see here. For any probability distribution, sigma pi is equal to 1. Sum of probabilities is equal to 1. Let me just add here k plus 2k, 3k, 5k, 6k, 7k, 8k. Therefore, is reduced to 9k square plus 8k is equal to 1. By mistake, you should not write it as 0. Remember carefully. Let me just add 3k, 5k, 6k, 7k, 8k. Now, this is reduced to 9k square plus 8k minus 1 is equal to 0. I'll be able to split the middle term. 9k square plus 9k minus k minus 1 is 0, which implies 9k times k plus 1 minus 1 into k plus 1 is equal to 0. You can just check 9k into k is 9k square, 9k into 1 is 9k, minus 1 into k is minus k, minus 1 into 1 is minus 1, which implies k plus 1 into 9k minus 1 is equal to 0. This is equal to 0. Just remember, I don't want to erase it and write again. Now for here I mean to say k plus 1 equal to 0 or 9k minus 1 is 0, which will imply you k is equal to minus 1 or I'll get k is 1 by 9. This is not possible. This case is ruled out because I am not supposed to have the values of any probability to be a negative number. Probability of any event should be always between 0 and 1. It shouldn't be below 0. It shouldn't be above 1 also. For impossible event, it is exactly 0. For sure event, it is exactly 1. For any other event, it is between fraction between 0 and 1. Therefore, value of k happens to be automatically 1. 1 by 9, sorry, automatically 1 by 9. Now, I need to think about p of x less than or equal to 2. What does it mean? It means p of x equal to 0 plus p of x equal to 1 plus p of x equal to 2. I am supposed to add these three, k plus 2k plus 2k. It is reduced to 5k. Therefore, my answer happens to be 5 by 9. Similarly, p of x greater than or equal to 3. I mean to say p of x equal to 3 plus p of x equal to 4 plus p of x equal to 5. That is the meaning. What is p of x equal to k? Here it is supposed to be 9k square plus k plus k plus k. Therefore, this is reduced to 9k square plus 3k. Therefore, this is anyway reduced to 9 by 81 plus 3 by 9. This is reduced to 1 by 9 plus 3 by 9. Therefore, which is reduced to 4 by 9 ultimately. Which gets reduced to 4 by 9. Which gets reduced to 4 by 9 ultimately. I repeat the whole process again. X takes value 0, 1, 2, 3, 4, 5. The corresponding probabilities are k, 2k, 2k, 9k square plus k plus k plus k. For any probability distribution, sum of probability of sigma pi is supposed to be 1. Let me just simplify here. K, 3k, 5k, 6k, 7k, 8k. 9k square plus 8k plus 1 is 0. Equal to 1. 9k square plus 8k minus 1 is 0. 9k square plus 8k is equal to 1. Therefore, I can split the middle term. After splitting the middle term, I end up with k is minus 1 or k is 1 by 9. K minus 1 is not possible. Most of the values here will be negative, which is not possible. Therefore, p of x less than or equal to 2 now is p of x equal to 0 plus x equal to 1, p of x equal to 2, which is pi k, which is pi by 9. X greater than or equal to 3, 9k square plus k, 9k square plus 3k, which is reduced to 9 by 81. 1 by 9 whole square is 1 by 81 plus 3 by 9, which gets reduced to 4 by 9 automatically, which gets reduced to 4 by 9. I think it's clear to everybody. It's not at all a difficult problem. Just you are supposed to remember one basic rule in any probability distribution. Sum of probabilities is supposed to be is equal to 1. That is the rule to be followed. And when it's a quadratic, I'll be getting two values per k, out of which the value which is not applicable should be ruled out. The value which is not applicable should be ruled out. Next question meant for today, it goes like this. A man speaks truth in 3 out of 5 cases. 2 coins are tossed and he reports that there are other than 2 heads. Find the probability that there are actually 2 heads. This is the question. Just see the question. I'll just show you the question. In this particular answer, I'll never use the word probability of man telling the truth. Just see how we go about it. When we toss 2 coins, S is equal to sample space HH, HT, TH, TT. Now let it be N of S is equal to 4. Let E1 be the event of having other than 2 heads. Other than 2 heads. Let E2 be the event of getting or having, either way you can write, getting 2 heads. Therefore, P of E1 here it is supposed to be is equal to HT, N of HT, TH, TT by N of S, which is supposed to be is equal to 3 by 4. P of E2, I am getting 2 heads, N of HH by N of S, which is equal to 1 by 4. P of E bar, sorry, I haven't written what E is, sorry. Let E be the event that, let E be the event, let E be the event that the man reports that there are other than 2 heads. That is what he reports. Let us imagine, let us assume. Now P of E bar E1, it means the denominator occurs first always. Therefore, I am getting other than 2 heads. The man reports that there are 2 heads. Therefore, here you mean to say the man is telling the truth here. You are getting other than 2 heads. He reports that there are 2 heads. Therefore, the man is telling the truth here. Now, the first statement tells you he tells truth in 3 out of 5 cases. Here you can write, here man tells the truth. tells the truth. You can write in the bracket. Okay, now P of E bar E2. Here you are getting two heads. He reports that there are other than two heads. He is telling a lie here. For in 2 by 5 cases, 2 out of 5 cases he will tell a lie. Here he tells a lie. Man tells a lie. Man tells a lie. Now E1, E2 are mutually exclusive. Mutually exclusive and exhaustive. What is the meaning of mutually exclusive now? Exclusiveness, intersection is empty. See here, there is no common element. What is the meaning of exhaustive? That sum is supposed to be probability is equal to 1, or the union is supposed to be sample space. Either you can say, therefore Bayes' theorem are applicable. This is the condition for Bayes' theorem to be applicable. Therefore Bayes' theorem is applicable. Let me write P of E is equal to P of E1 into P of E bar E1 plus P of E2 into P of E bar E2. This result is called total probability theorem. This is by total probability theorem. This rule is called total probability theorem. Let me substitute the values. 3 by 4 into 3 by 5 plus 1 by 4 into 2 by 5, which is reduced to 11 by 20. Now required probability is equal to P of E2 bar E. He reports that there are other than two heads. Now I mean to say there are exactly two heads. That is what I am supposed to do. This is nothing but P of E2 intersection E by P of E by definition of conditional probability. Numerator can be written as P of E2 into P of E bar E2 divided by P of E. Here use the conditional probability here, P of E intersection E2 by P of E2. Cross multiply, I will get the numerator. Let me just substitute the values. I mean to say 1 by 4 into 2 by 5 divided by 11 by 20, which is reduced to 2 by 11. Answer happens to be 2 by 11. Let me just explain once again. When we toss two coins, sample space HH, HT, TH, N of S is 4. E1 be the event of having other than two heads. E2 be the event of having other than exactly two heads. Here I will get N of HT, TH, TT by N of S 3 by 4. Two heads, N of H is 1 by 4. That E be the event that the man reports that there are other than two heads. I never use the word he tells the truth in any in the probability of any such problem. If E bar E1 denominator occurs first, here you mean to say you are getting other than two heads. The man reports that there are other than two heads. Therefore, he is telling the truth here. For the first statement, it says he tells the truth in 3 out of 5 cases, 3 by 5. P of E bar E2, he is getting two heads. He reports that there are other than two heads. He is telling a lie, 2 by 5. E1, E2 are mutually exclusive and exhaustive. Therefore, Bayes' theorem this is a condition for Bayes' theorem to be applicable. Write it out if you want. It's better always. The teacher knows that you understood the concept and then written. P of E, P of E1 to P of E bar E1, P of E2 to P of E bar E2. This is the rule by total probability theorem. 3 by 4 into 3 by 5 plus 1 by 4 into 2 by 5. 2 plus 9 is 11, 11 by 20. Required probability of E2 bar E. The man reports that there are other than two heads. There are exactly two heads here. What is the probability there are exactly two heads? If E2 intersection E by P of E by definition of conditional probability. Numerator becomes because of conditional probability with P of E2 into P of E bar E2. Just use the rule P of E bar E2 and cross multiply. I will get the numerator. 1 by 4 and 2 by 5 by 11 by 20 happens to be 2 by 11. Therefore, my answer happens to be 2 by 11. Therefore, it's almost 15 minutes. If there is any correction, I'll just add up the correction here. I hope there is no correction. Let me just check. Rest we'll discuss in the next video. Thank you students for patient watching. Just a small correction. in one of the places for P of E bar E1, I said he is getting the truth here. E is nothing but getting other than 2 heads. By mistake I said E is getting 2 heads. There is, in one of the places. Anyway, it's corrected when I was explaining for the second time. Anyway, I understand that particular part thoroughly, and then there's a small error in explanation only at the beginning. Then for the second time it is explained properly. Anyway, see to it properly and then write. What is P of E bar E1? You just understand and then write and then do. Thank you.